this. I'll try to be more faster to explain these kind of terms. So we arrive to the discount return, the alpha omega term over here, which means to reduce the summation of the rewards of the future, and that is by getting this kind of terms, the future rewards are not more important than the current possible rewards. So introducing this kind of term will help us to reduce the continuity of getting rewards and limit the assumption of the expected coming returns with focusing with the immediate and the next very coming soon returns. So this is the equation. For example, do you want to have like 5 ringgit now, or you want to have the same 5 ringgit in after 5 years? It is always better to have it now. All right, so to be faster, I'll just go to these kind of questions and answers. How to determine how much rewards does the agent get in each action? There are policies which can be defined as the roles or the maps that give the states the probabilities to select each possible action from each state. Every action will be done in each state will be generated a reward. How much? That depends on the policies, and that will lead us to the optimal policies. All right, this is the optimal policies. Let's call it pi. So if we have pi is better than pi dash, that means this policy pi is better than pi dash. Right? Simple as that. If this policy get us more rewards than this another policy, so we will stick with the first policy. All right. So this policy is better, which is pi. But how to know it is better? We will call it optimal state of action, because this following this kind of state value that will get us better rewards. So we call it optimal state value function, which defined in this equation. V star S equal to max V pi S. All right. In another word, V star gives the largest expected return achievable by this policy pi for each state. But how policy knows if the action is good or not? All right, that is interesting. Value function are function of states or state action pair that estimates how good it is for the agent to be in a given state, or how good it is for the agent to perform given action in the given state. So this will lead to another question: how RL algorithm learn? Actually, from the previous equation, V star S equal to the maximum of a V pi of S. We can combine that to get the optimal action value function. Instead of just having the state, we are also having the action, and that will lead us to this optimal action value function. The optimal policy has the optimal action value function, which called optimal Q function, which is here. And this optimal Q function, which means the best state and action to be generating better rewards. So instead of just having the best state, no, it is having the best state and the best action to be generating better results. And that will be more clear, I think, the very coming example, hopefully. But let's now focus on this, how to know this is the best action and state using this kind of Bellman optimal equation, which is very important, which is actually is going to be used in the coming stages. Q star S of A equal to the E estimated rewards plus the learned value over here. So in state of for any state of action pair of SA at any time of t, the expected return from starting state is selecting actions and following the optimal policy is given to be the expected rewards we get from the taking action in the state is which is reward t plus 1 plus the maximum expected discount return that can be achievable from any possible next state action pair of s. Yeah, that was very interesting to be read. But to explain it, here we have expected term for the rewards here rt plus 1 plus the discounted value from the maximum q value, which is given here in this equation, the optimal action value. This is will be for the next expected maximum action and value. So from this example will lead us to program and to estimate how to design quadcopter. So yeah, it is very interesting to explain this example. So until now we know the Q-learning. We have this equation which will generate as the best action and state with the estimation of the best action and state to get best rewards. So let's have this example mentioned here. We have a lizard and we have this kind of game. If the lizard goes to this area, it will get, the first block, it will get -1. And if it gets to this cricket, it will have +1. And if it comes to this 5 crickets, it will get +10 and the game over. And if it comes to this bird, it will have -10 and will also have game over. So each empty block is -1. Each here the last cricket with 5 crickets, we will have +10, and to the bird we will have -10, and in these two states we'll have game over. So let's start with the Q value game, and this is the table representing this game. We will have this kind of matrix which have 4 states, left, right, up and down, and 4 and the 9 empty spaces which are here, 1 2 3 4 5 6 7 8 9 10. So now we want this lizard to explore and to learn according to this equation. All right, so the episodes, now we will set some standard numbers for the episodes that we want the lizard to play. Let's say that we want the lizard to play 5 episodes. Episode means it is playing until it win or lose. That means episodes, yeah. In each episode, the lizard starts out by choosing an action because it started from 0 state and from 0 action. So it is going to start new action to another new state. But there is a question over here. Let's return back to this box. Here we said the empty block is -1 and here is -1. So which one will the lizard select? Here is another interesting question. Because all Q values are set to 0 at the start, so there is no way for the lizard to differentiate between them to discover which is considered better, right? So what action does that start with? And this is a very good question. Let me check. Yeah, we have 1 minute to go. For the reason, we need to introduce a term called exploration and exploitation. This will help us to understand how does this agent think to select which action and which state to go. So even in life, in our life as human being, we have these kind of terms. So it is good to introduce this new term which called how to select, how to choose. So exploration is the to act to explore the environment, and exploitation is the act how to act just to win as much possible. As much rewards as maximum rewards as possible.